Hi everyone, welcome back to my math teaching online. So in this video today, I would like to show you the derivative of the inverse function. So there will be two sections for this. So this is the first section. I'm going to talk about the how we find derivative of this inverse function. So let's take a look at the question on the board. So given the function f of x, assume that the derivative of f of prime of x exists, find the derivative of the inverse function of f of x. And we have a notation here. To find derivative inverse function, you put 1 and then put the derivative underneath it. Now, why is this? The idea is just like this. If you have a fraction 3 over 4, so what is the inverse of this fraction? Of course, it's 4 over 3, right? And 4 over 3 is the same like you put 1 on the top and you divide by 3 over 4. So this and this, exactly the same. So that's why this notation comes from. So the derivative inverse function equals 1 over the derivative of the function. So now let's go into example 1. It says let g be the arc-tan function. What is g of 1? So I have shown you that the arc-tan function, the same like this notation, right? This and this is just exactly the same. So now they say let g be the arc-tan function, which is the inverse of the tan function. So our original function here is y equal tan x, right? And now we want to find y prime of the tan minus 1. That's what we want to find. And we name this as the same like g prime. Okay, so now let's say y equal 10x. Or we can say y equal 10 of 1. But what is 10 of 1? You know that if you have special triangle, if this is 45 degrees or pi over 4, the same like in radian, and the 10 is just equal sine over cos. And if the sine over the cos here exactly the same number divided by same number, so it turned out 10 of pi over 4 is 1, right? So 10 of pi over 4 is 1, it means 10 minus 1 of 1 equals pi over 4, right? Because we know that if we hit this function in our calculator, it converts into the angle for us, right? So the ratio of 10 is 1, it will convert it into the angle. So the inverse of 10 is just the angle itself, okay? So now let's do the derivative of this one. So y prime will be secant square x, okay? Just say x for now, okay? So y prime, we do derivative of this one, of this function, right? Y prime equals secant square x. In trigonometric, we also learn that we can rewrite this as 1 plus 10 square x as well, right? So the derivative of the of the g prime of 1 is just equal 1 over 1 plus 10 square. Now we know the angle of 1 is pi over 4. So that is the g prime of 1. That's the solution of it. 10 squared pi over 4. Okay, so that's how we derivative of this inverse function. Now, let's say if you have another example, let's say find g of 1 square root 3, right? So in this question, to find the g prime of 1 over square root 3. So it means our function is original is y 10 of 1 over square root 3. So let's find out what the inverse of it. The inverse of this function is the angle, right? What is the angle of 1 over square root 3? So let's say this is 1 square root 3. What angle is it? This is 30 degrees. Remember, refer back to Spencer triangle. Opposite of 30 degrees 1, adjacent is square root 3, and this is 2. So the angle 10 minus 1 here, the inverse of this is the angle, right? And the angle here is 30 degrees, which is pi over 6 in radian. So now to find the g prime of 1 over square root 3, we will find the inverse of this angle. So that the same, like 1 adding with 10 square, because like secant square pi over 6, right? Our angle is pi over 6. But we can convert into this as well. So 1 over 1 10 square pi over 6 is our answer in this case. So that is about the how to find the inverse of the trigonometric function. So now let's go to the next board. Let's go to next board. We're talking about the second example. Okay. So in the second example, here, I will talk about the polynomial function. We'll not talk about trig anymore. We talk about polynomial function. So let given the function is f of x equal minus x to the power 3 plus 2x plus 1. Find g prime of 2. When g prime of 2 equal the inverse function of this fx of 2, we should name another name, right? Actually, we don't have to. We should ignore this one. We don't have to. Just say the inverse of f of 2, right? But we just like to be fancy. We try to use another name. So I just toss in here just in case you come up with this question about g prime and x, f of x, f prime of x. So you're familiar with that. So actually g prime of 2 is just like the inverse of f of 2, okay? So in this question, we're talking about the restriction of. Hi everyone. So I'm going to continue to the second board about the derivative of inverse function. So let's take a look at the example. So example 2, we have f of x equal minus x to the power 3 plus 2x plus 1. So this is a polynomial function. And we want to find g prime of 2. When g prime of 2 equal the inverse function, derivative of the inverse function of f of x, of f of 2. Okay. Now, in this question, the solution is we have to restrict f to an interval so that the inverse function g is defined in an interval containing the indicated point and find the derivative of the inverse function. So we have to find x in such that f of x equal 2. Now, why is this going on? Why we have to restrict? We have to talking about the restriction because you remember for the inverse function, not on the function you can find its inverse, right? And if you cannot find its inverse function, then you cannot find derivative of the inverse function, obviously. And let's talk about the explanation for the domain, right? So let's say if I have a function. Let's say if I have a parabola function. And let's say from here to here minus 1. Let's say right here to 1. Now, obviously, if this function have an inverse or not, the whole function here f of x, if you use a vertical line test, horizontal line test, you know that for two x1 and x2 here, given the same y. And by horizontal line test, we know that we cannot have different x coordinate to give the same y coordinate, which is you cannot take the inverse of this function. So to take inverse of this function, you have to restrict the domain from 0 to 1, either from 0 to 1 or from 0 to minus 1. Let's say if I restrict it, I just restrict from the domain from 0 to 1. Then do I have the inverse of this branch on the right-hand side? Yes, I can draw it, right? Obviously, over the line equal y equal x, the inverse of this function is just something like this, right? And that's why we're talking about the restriction of the domain when we take the inverse function. And the same like in the trigonometric function as well. If you have the function sine of x, which is something like this, and if you take the whole function, you cannot find its inverse. But if you restrict the domain from minus pi over 2 to pi over 2, then yes, you can have an inverse function. You can draw it. This is pi over 2, and this is minus pi over 2, and this is minus 1, and this 1. Remember, inverse is just the interchange between x and y coordinate, right? So the y minus 1, 1 in the original function become an x in the inverse function, minus 1, 1. The range in the x in the original function minus pi over 2 to pi over 2 become the range in the inverse function minus pi over 2 to pi over 2. Now, to find its inverse, you have to cut off all of this branch, and you just want to take from here to here, right? And therefore, you can draw the inverse function, which is something like this. That's the inverse of the trigonometric function. And the same for cos as well, right? For tan. So this is just the explanation, okay? Nothing to do with the question. So let's get back to the question now. My point is just to explain to you that we have to restrict the domain to have its inverse function. And therefore, we can find its derivative function. So now let's see in here, that's why the solution in here, we say we have to restrict the function of f to an interval so that the inverse function g is defined in an interval containing the indicated point and find the derivative of the inverse function. So how are we going to restrict the domain at the point here? The way we do, we have to find x in such that f of x equal 2. So how do we find to make fx equal 2? So let's say if we have an x is minus 1. If this work, let's say minus 1 to the power 3, we plug in the function, right? Plus 2 times minus 1 plus 1. So this becomes minus 1, minus 2, plus 1. So we get minus 2, which is not acceptable because we want f of x equal 2. This is our indicated point restriction. So let's try another one. Let's say f of 1. F of 1 is minus 1 to power 3, adding with 2 times 1 plus 1. And this is minus 1, this is plus 1, so cancel, cancel, 2 times 1 is 2. So yes. So now we know f of 1 is okay. So our x must be equal 1. That's the indicated point right here. To have the inverse function in the interval of restriction. So x must be equal 1 to find the g prime of 2, which is the inverse of f prime of 2. Okay, so now let's take the derivative of our inverse function. So derivative of the function, not inverse, sorry. We take derivative of the f prime of x. What is derivative of that? Let's follow the function 3 minus, so that become minus 3x squared, right? Yes, plus 2. Plus 2. So that is the derivative of this. So now we have to find the derivative of f prime of 1. F prime of 1 is minus 3 times 1 squared plus 2, which is minus 3 plus 2 is minus 1. So g prime of 2 will be equal 1 over f prime of 1. So that's the answer. So now will be equal, f prime of 1 is minus 1. So 1 over minus 1 equal minus 1. So g prime of 2, we found it, equal minus 1. So that's the idea. When you find the inverse of this function, derivative of the inverse of this function. Okay, now I'm going to get into another example for you to see. Okay, so maybe give you 2 examples. So bear with me, sorry for taking time to erase my board. Bear with me for this question. So I'm going to give you another example, okay? So let's say I have a function f of x equal x minus 1 times with x minus 2 times with x minus 3. So this is a polynomial function, right? And the question is, find g prime of 6. Now, solution. Again, we have to find a domain restriction. What indicated point of x to give us what x? So find x such that f of x equals 6. We want to do that first, right? For it valid, we have to do this first. So find x such that f of x equals 6. So now let's find. So let's say if I randomly select a f of 4, let's find out. So substitute in this with 4 minus 1 times with 4 minus 2 times with 4 minus 3. So what is equal? 3 times with 2 times with 1. And 3 times 2 times 1 is 6. So we find out x. So x here have to be equal 4. Okay? So now let's take the derivative of this function. Now unfortunately, if we take derivative of this function, is like three brackets like that. It's kind of complicated. So we have to combine them first. Okay? So let me combine this one, this bracket with that bracket. So f of x equal x times x is x squared, x times minus 2x, and minus 1x, and plus 2. So simplify of this function, we have x squared minus 3x plus 2, right? Okay, now we also can do the product rule now to take derivative, but why don't we just multiply them together? So maybe that would be easier. Okay, so f of x will be equal, let's tie them together. X squared times x is x to the power 3. X squared times minus 3x squared. 3x times x is minus 3x squared. Right? 3x times x is minus 3x squared. 3x times minus 3 is plus 9x plus 2x minus 6. So f of x will be equal x to the power 3 minus 6x squared plus 11x minus 6. So after we combine all of this, we get the function. Now we can find derivative of this, right? So derivative of this function will be equal 3x squared minus 12x plus 11. And this is 0, right? So now what do we do next? Now we have to find the derivative of f prime of 4. What is f prime of 4? All what we do is substitute in the derivative function, which is 3 times 4 squared minus 12 times 4 plus 11. So what this become? 4 times 4 is 16. 16 times 3, 48. So 48 minus 48 plus 11. So f prime of 4 is 11. Okay, so I have to, I need more room to resolve this. So I'm going to have to erase the part of here. Okay, we continue with it. And again, sorry for my erasing on the bar. Bear with me 1 second. Okay. So now we have f prime of 4 equal 11. We have f prime of 4 equal 11. So g prime of 6 will be equal 1 over f prime of 4, which is 1 over 11. So that's our answer. So that's how we find the derivative based on the domain restriction, based on the defined point, indicate interval of the indicated point. So I hope you enjoy my teaching lesson today. It's a little bit complicated, but I hope you understand. And the next section of the video, I still want to go with you over the derivative of the inverse of function, but will be the application of how to use a formula to find the derivative. And the formula I already introduced to you in the previous video, right? So we have a formula for derivative of sine x, which is cos x, and then r sine x will be 1 over square root 1 minus x squared, something like that. We get into the introduction of that already in the previous video. So if you forget, you can rewind the video, right? In my course, you can rewind backward from the previous lecture, video lecture, and learn from that and review from that. So that is a very benefit of learning online, like, because if we are teaching in the classroom, the lesson gone and you cannot usually I think that if you use smart board, you still can record it, but most of students just keep learning the new lesson each day in the classroom, and they don't bother to rewind the smart board. And sometimes I think it's just available to the to the teacher unless like you can get it from the email from the teacher. But anyway, I'm wander around the topic a little bit. I'd like to have a little social talk with on my invisible student. Anyway, I hope you enjoy my video and see you in the next video. Thank you for watching, and don't forget to give me a thumb in YouTube and hit subscribe to my channel. Thank you. Bye for now.